These are the solutions for the second assignment, assignment number 15, systems of linear equations. So keep in mind, no calculator on these. You can see my coffee spilled there. So we have to think of methods of solution without a calculator. Set the y equal to 3 in the second equation. So systems of linear equations, we're trying to find a point of intersection if there is one, or maybe there's infinitely many. And then solve it out and you get -2, 3. You already knew the 3. That got substituted in for the y. Number 2, okay, so here's the work. Multiplying the top by a -3 and then adding that to the bottom will produce y equals 2. So you have to try to create opposites. It's called the method of elimination. Try to create opposites. Certainly you can use guess and check on this. So, you know, if you had no clue, is 10-2 the right answer? It has to work in both. It works in the top, it gives you 6 on both sides, and then it works in the bottom, it gives you 38 on both sides. So there also is the way of substituting as a problem-solving strategy for systems, so don't forget that, especially on number 3. You look at this and go, holy smokes, there's not any way I would know of doing this, but you know, you can substitute in all of these values. So 1, 1 is not true because 2 times 2 is 4. You'd add 1 plus 1 here if it was true. That's not the same. So you get down to C, and you'll see that 0.75 plus 0.5 is 1.25 times 2 is 2.5. And then also 0.75 minus 0.5 is 0.25. So the whole guess and check thing is on these assignments and these problem types. What value C makes the following system have infinite number of solutions? So you are trying to turn one line into the other perfectly when this is the case, or just on the left side when it's no solution. How can I turn one line into the other? So I have to multiply the top by 1.5 to get from it to the bottom. But 4 times 1.5 is 6, 2 times 1.5 is 3, 2 times 1.5 is 3. So it must be 3 for C. So you try to turn one line into the other, either all the way through or just on one side. Problem 5. So here we go, a system of equations. No calculator, so that means a little bit of work. I chose to eliminate the y's by multiplying the top by -4 and the bottom by 3. Do that carefully, all the way left to right, add them, and you end up with x equals 3. And then we want the cost of 12 apples. Apples is x, the number of them. So 12 times 3, 36. You did not need the y equals 1. Problem 6, how many solutions to the following? Well, you can add all the way through, you get 0 equals 0. So when the variables drop out and it's true, it's an infinite number of solutions. Notice that we turn one line into the other all the way across. It's just off by a negative. Problem 7, still I'm not using a calculator here. So sum total is 60 and there are twice as many girls as boys. So you got to be careful here. So you have to think of numbers. So twice as, so like if there's 40 girls, then 20 boys would have to be. But you're trying to make them equal with that equation. So it looks opposite when you set it up. And be careful with these kinds of systems where you're comparing values like that. Oftentimes it looks not to be right, but remember that you're trying to make them equal. With the two equations, have a solution in which of the following choices. Okay, so you're solving. I just substituted them in. -2, -2 is true in both. And you know, sometimes, you know, probably the better way there, and let me show this work, is that you set them equal to each other and solve. So you would have 3x here and negative 6 over here, so negative 2 would be x. And so then from there, you would put it into either one and you would get negative 2. So that's probably the better work on that. Problem 9, here's your setup. This is the two sets of three values kind of system. So you pair them up, and now we're going to multiply by 3 everywhere. And then you get this result, and then we're going to multiply that by negative 2. Kind of a hard system in doing all of that. And when you add them together, you get y equals 6. And we want 1 cup of vanilla. Of course, that's what x is. And so you need to replace that, and I chose this one here, making x equal to 3. So a little bit of work there. Definitely one of the harder ones because of the fractions there. But you set them up, multiply to eliminate the denominators by 3 everywhere. There's that theme again. Then multiply the second one by negative 2 and add together these two. And then you get y equals 6 and replace that to get x equals 3. Problem 10. Okay, so which one? So you have to see it like this. So there's 3 variables, and then which one of these is true in all 3? And that this literally, there's no other way that we have of doing this other than substitute in as far as no calculator goes. Okay, so substitute them in. This is A, B, and C, the output, to see which one of those is true in all 3. Now we finally get to a calculator, which I wouldn't care if you used any of the apps that I've shown you, especially the PolySimult 2 app to do this. But you have to see the two sets of 3 values. Over here I did show the work way. I created opposites on the x by multiplying the top by negative 4 and the bottom by 3 and adding. And so 3 halves is, I'm sorry, 1 half is y, and then you get 3 halves for x. And then they want to know 17 balloons and 10 hats. So you take 17 times 1.5 for x plus 10 times 1/2 for y, or 0.5. So there is the calculator way of doing this if you have that app. Other than that, you have to really solve things out there. Kind of a harder problem. Here's a good solid problem. This is the type of system where you're comparing values. You have one set of 3 values. The 2, the 3, and this 150 go together. They're all pound amounts. And then you have 6 times as many physics books as there are chemistry books. So you got to do 6 times the chemistry to be equal to the physics. So it's opposite again to make them equal. And so you can put 6y in for x here. So 2 times 6y is 12y, and then solve this out. And you get 60 for x, and then 10 for y when you do that. And here, this is the 4 values one, with 1 being the total. You saw that in a problem earlier where it was messed up when one of the variables was moved to the other side. So 5, 13, and 66 represent dollar amounts, and then the total being 10. And so I would just, again, use elimination to do this. I multiplied everything by negative 5 on the bottom row, added them, and you get 8y equals 16 over here. So y is 2, and then that gets replaced. X is 8, so 8, 2 is the solution. And that is assignment 2 in test prep.